All right, good morning, good afternoon, good evening, wherever you are. This review for the upcoming midterm exam um, will probably take a couple of hours, although I'm going to um, load it up as YouTube videos or audios in little bits so that you don't have to listen to the entire uh, presentation in order for you to find one piece of information that you want. Let me reiterate what is written down here, that this review is meant as an aid to your studying. It's not going to substitute for reading the descriptive text and studying Maya's histology. About 75% of what you will need to know for the upcoming midterm exam will be covered in this review, I hope. But the other parts, some of the more theoretical aspects of the histological features that you're studying will require that you read the descriptive texts, and Maya's histology has far more slides in than those that I will cover here. So we're going to start with staining. As I mentioned, there are only a few stains that you need to know for this exam. Elastic is one of them. It stains elastin black. Our old friend hematoxylin and eosin, which stains nucleic acids blue or purple, and all other proteins red. Masson's trichrome is another one that you need to know. It's a general connective tissue stain which stains muscles, erythrocytes, etc. Collagen, red, and collagen is blue. And then the periodic acid Schiff one is specifically used for staining basement membranes and other polysaccharides, but it stains features which have a lot of sugars in them. And then there is the Polychrome stain, which is equivalent to the trichrome stain, and as I've put down here, trichrome, which can be Masson's or Mallory's, but they're the same kind of thing. So you could just identify a slide as trichrome or Masson's or Mallory's or even Polychrome. They're all pretty much the same. The others you haven't looked at yet, so don't worry about them. So let's look at the periodic acid Schiff stain, which is specifically used to stain carbohydrates, and basement membranes have a lot of carbohydrates in them. The PAS stain also stains erythrocytes, this orange color. So these are small veins or arteries here with erythrocytes in them. Masson's trichrome specifically stains connective tissue blue. Let's look across here. Stains connective tissue blue, stains muscle red. I have got an image here of cardiac muscle, but the same would be true with smooth muscle or skeletal muscle. And where one has an overlap of muscle and connective tissue, one sees this purplish stain. Mix red and blue together, you get purple. And Masson's trichrome, the Polychrome stain, also stains erythrocytes this red color. Polychrome stain is also used to stain the pituitary. It's a fairly specific stain for the pituitary, and I just wanted to show that it stains connective tissues here, and here's a larger larger piece of connective tissue. It stains it a blue color, pretty much the way Masson's trichrome does, and also stains erythrocytes this orange color. But it's a pretty specific stain for the pituitary. And finally, the elastic stain is one that you should know and is very easy to recognize because it stains elastic fibers black and connective tissue a reddish pale pink color. And as you can see, there's also elastica in the lining of this blood vessel here. And the nuclei of the endothelial cells which line this blood vessel stain black, not because they have elastic tissue in them. It's just a feature of these nuclei which stain black for some reason. So elastic fibers stain black with elastic stain. Collagen, and I could well ask you, show you a slide like this and say, name this tissue here, and you would have to say collagen.